3 beakers here which contain the solutions with the chemical formulas shown on your screen. I've added a power strip to my collection here so that I can easily turn the power to the light bulb on and off. We're simply going to use the light bulb in order to decide if each of these solutions conducts electricity. So our first solution is definitely a conductor of electricity. Turn my power strip off, light my prongs, move on to my second solution. It is also a conductor of electricity. And on down the line. To my third solution. And all 3 of these solutions are excellent conductors of electricity. The unexpected result in that little demonstration was really the HCl and the H2SO4. The barium hydroxide, you likely predicted that it would light up the light bulb because it consists of a metal, barium, and a polyatomic ion, hydroxide, meaning that this is an ionic compound, dissolves into ions, and conducts electricity exactly like you would expect. The HCl and the H2SO4, however, at first glance seem like they maybe shouldn't conduct electricity because they're made of entirely nonmetals. Possibly you had predicted that the H2SO4 would conduct electricity because you may have noticed the polyatomic ion in there, and we've learned that things with polyatomic ions do often conduct electricity. These 2 compounds are actually part of a third category of chemical compounds, the acids. Up to this point in time, we've encountered ionic compounds, molecular compounds, and now we're going to add acids to our list of types of chemical compounds. These 2 compounds are called hydrochloric acid and sulfuric acid, and those are probably names that you're familiar with. Acids are molecules that give up hydrogen ions in water. The fact that they give up these hydrogen ions causes them to leave behind a different ion, often called the parent ion, and we end up with the positive and negative ions in solution and the conductivity that we saw, just like with the ionic compounds. There are a wide variety of acids. However, we're only going to worry about the 6 most common acids: hydrochloric, nitric, sulfuric, carbonic, phosphoric, and acetic acid. The formulas for these acids are related to their parent ion, as are their names. Probably the most common laboratory acid is hydrochloric acid. It's made from the chloride ion, and when hydrogen chloride is dissolved in water or becomes aqueous, it gets the name hydrochloric acid. The remainder of these common acids are made from polyatomic ions, all of which end ATE. The rule for naming acids is that if the parent ion ends in ATE, the acid name will be changed to end in ic. Thus, nitrate becomes nitric acid, sulfate becomes sulfuric acid, and so on and so forth. If you need to figure out how many hydrogen ions go in a particular acid, you simply have to look at the charge on the parent ion. Knowing that the hydrogen ion has a positive 1 charge, you need enough hydrogen ions to counteract the negative charge on the parent ion. And that's the reason that nitric acid has 1 hydrogen, sulfuric acid has 2 hydrogens, and something like phosphoric acid has 3 hydrogens. Take a moment and add this table to your Chem Study resource sheet. You can put it with your polyatomic ions and your Roman numerals and prefixes. These acids and their names will be provided for you on a test.